Hi there and welcome back to Having Fun with Chemical Formulas. I hope Activity 3 was useful, and by this point you should be getting fairly familiar with using atoms, naming the atoms, and generally getting a gist of how the formulas work. In this tutorial I'm going to explain a wee bit about ions. We're not going to go into any great detail, but this is going to be useful for us to actually start building ionic compounds and formulae later on. So here's some explanation. You're now familiar that atoms basically are made up of electrons. However, work on the principle that atoms really want to have a full outer shell. Now, you probably will have dealt with shells in your classes, but later on I will be talking about shells in another tutorial. But what I'd like you to understand is that basically atoms want to either get rid of electrons or gain electrons to complete their outer shell. Electrons complete the atom. Now, if they gain or lose an electron, they then no longer become an atom, they are now called an ion. If you lose electrons to gain a complete outer shell, then we classify you as being positively charged. As a result, the atom is now a cation. For example, sodium is written as Na+, it's positively charged. If you're gaining an electron, and this happens generally with non-metals to complete the outer shell, you become negatively charged, and then you are termed an anion. For example, chlorine. This is written as Cl-. So you can see that sodium has lost electron and it becomes positive, and chlorine has gained an electron, so it becomes negative. Now, the number of electrons that you gain or lose is then determined by how many it requires to fill the outer shell. So, in the case of sodium, sodium has to lose one electron. Now, we can see that the number of electrons then can be written as a superscript after the chemical. If you look at sodium here, it's just got a single plus. That means it's lost one electron. Chlorine, however, has gained one electron. This means it's Cl-. Basically what we find with ions is that the ions join positive to negative until they have a complete ionic charge of 0. So, that gives you a brief overview as to how the ions work. Now what I'd like to do is to have a look at the periodic table, because this is very useful in determining what the ions are for each of the various atoms. You can see here we've got a periodic table. Now, the periodic table is split into two types of elements. We've got the metals on one side, and we've got the non-metals on the other side. In class you will have gone through this, but basically most of the elements are metals, with a few being non-metals, going from carbon, which is in number 6, all the way across to the right. And what we find is that each of the groups, which basically are the columns, can either gain or lose an electrons, and atoms are placed in specific groups depending on how many electrons they can lose or gain in their outer shell. So for example here, you can see that the first column will lose one electron. Remember, if you lose an electron, you are positively charged. So because it loses one, it's called a +1 ion. So lithium will be Li+, sodium will be Na+, potassium will be K+, and so forth and so on. In the second column, you can see they lose 2 electrons. So because they lose them, they become positively charged. They've lost 2 electrons, so the superscript will be 2+. For example, beryllium, Be2+, magnesium, Mg2+, calcium, Ca2+. These elements in the middle here are basically called the transition metals, and we will not deal with those at this point. However, we will touch on a couple of them later on in the course. If we go to column 13 here, we can see that these elements actually have 3 electrons that they can lose. So boron becomes B3+, aluminium, Al3+, etc. Now, group 14, as you can see here, basically has no charge at all. This is because it's a stable set of elements, because they have a half-filled outer shell, so they do not form ions. Moving on, if we look at column 15, these elements start gaining electrons. They are our anions. Because they're gaining electrons, they are completing their outer shell. Now, this group require 3 electrons to complete their outer shell. So nitrogen will have the ion N3-. Phosphorus will be P3-. As we move further to the right, it takes less electrons to fill up the outer shell. So group 16 consists of the 2- ions. They require 2 electrons to fill their outer shell. So oxygen becomes O2-, sulfur becomes S2-, selenium becomes Se2-. The last group here, group 17, only require 1 electron to fill their outer shell. These are called the halogens, and basically they have fluorine, which is at the top, which has F1-, chlorine, Cl-, bromine, Br-, iodine, I-. The last column, called the noble gases or inert gases, have a complete outer shell. As a result, they do not form any ions. Therefore, they are very unreactive. So, what we are going to be looking at for the next few tutorials is the interaction between the positive cations, so those are the +1s, the +2s, and the +3s, and the negative anions, which are the -3s, -2s, and -1s. Just to recap, note that you form a ion depending on the number of electrons that you've got in the outer shell. Remember, if you've got only a few, you're going to lose them. If you've got a lot, you're going to gain them. So if you look at the bottom here, you can see that group 1 only has 1 in their outer shell. Group 2 has 2. 3, 4 basically goes up to stable, 4 being stable. 5, 6, and 7, they all gain electrons. Okay, well, I hope this was useful. Now what I'm going to ask you to do is have a go at activity 4. In this, you're going to use this periodic table to build up a table, which is going to firstly look at whether an element is a metal or a non-metal. It's also going to look at what the number of electrons in their outer shell, and finally you're going to determine what the ion is dependent on its position in the periodic table. I hope this was useful. Good luck, and I'll see you in the next tutorial. Thank you for watching.